In section R4, we're going to talk about factoring. It's on page 21 on your textbook if you want to take a look at that as well. Factoring is basically multiplying. Previously, what we did is take a problem like 2 times the quantity of x plus 2, and we would use the distributive property and multiply the 2 by both of the terms that are inside the parentheses. So we took 2 times x for 2x and 2 times 2 and came up with 4. Here, if we were asked to factor 2x plus 4, what we would do is find what factors or multipliers they have in common and unmultiply it. So our answer to that would be 2 times the quantity of x plus 2. What we're going to take a look at in this one is terms with common factors. We're going to be using the distributive property. So if we had AB plus AC, and remember the A and the B and the A and the C next to each other means that they're multiplied together, then we could go ahead and factor that or use the distributive property and say that's the same as A times the quantity of B plus C. So using numbers, this would look like 2 times B plus 2 times C. 2 is common to both of them, so we put that on the outside, and inside the parentheses we have B plus C. We can check our answer by going back and using the distributive property on the right and seeing that we get exactly what we have on the left. There are a couple of things that we want to do when we're trying to find out what they have in common. The first one is to look for the largest possible number that is a factor of every term. And the second thing is to look for each variable in common. You want to do one variable or one letter at a time and find the largest possible exponent that is in common. So we're going to take a look at several problems and going through these two steps. In example 1, if we were asked to factor it, we have 15 plus 10x minus 5x to the second. The first thing that we do is we look at the 15, the 10, and the 5 and see if they have anything in common as far as numbers go. They do. 5 will divide into each of those numbers evenly. So we put the 5 on the outside, and then because we have 3 terms, we're going to have 3 question marks or 3 blanks to fill in. We need to multiply the 5 on the outside times the first question mark to get back to 15. So 5 times 3 will give us 15. That takes care of the first term. The second term, we have to multiply 5 by something to get 10. That's going to be a 2, and we need the letter that goes with it for an x. And then the last one, we have minus 5x to the second. So we're going to need another x to the second term. So factoring this problem, it looks like 5 on the outside, inside the parentheses 3 plus 2x minus x to the second. And we can go back through and use the distributive property and multiply that back and get what we had on the first line. This one had only numbers in common because all of them don't have letters. The 15 is just a number with no letter. Now we're going to look at example B. Example B looks a little bit different than the first one because they have numbers, they all have x's, and they all have y's. So the first thing to do is to look at the 12 and the negative 20 and see what factors that they have in common for numbers. So we want to see what numbers divide evenly into both 12 and 20. Well, 2 does, but that would leave us with something else left over. So 4 is the largest number that will divide evenly into both 12 and 20. So we put that on the outside. The next thing that we do is we look for the variables or the letters that they have in common. We're going to start with the x. The first one has x to the second. The second term has x to the third. So the most x's that they have in common is going to be the 2. So we put x to the second on the outside with the 4. And then we go to our y, and the first one has y to the second, so it has 2 y's, and the last one only has 1. So 1 is the most that they have in common or that they share. And now we have 2 blanks to fill in, or 2 question marks to fill in. So we know that we need 4 times something to give us 12, so we need another 3. And if we look at what we have on the outside, we have 2 x's. Well, for the 12x to the second y to the second, we have 2 x's. We don't need any more x's. On the outside, we have 1 y, but for the first term, we need 2 y's. So we're going to make and put another y there with it. So we have the 3y is going to be our first term inside the parentheses. Now we have to multiply 4 times something to get 20. The number that we need is 5, so we put that inside the parentheses as well in the second spot where the second question mark is. On the outside of our expression, we have x to the second, but we need 3 of them for 20x to the third y. That means that we need 1 more x, so we put that down. On the y's, we have 1 on the outside, and our 20x to the third y term only has 1, so we don't need any more. So there's our answer as you can see it. We can take this and we can go back and multiply it out. So we take 4x to the second y times 3y, and we take 4x to the second y times negative 5x. That will give us what's on the first line for example 1b. Here's several more examples that are not in the textbook. We look at on number 1, the 40 and the 20, and we do our numbers first. This one is pretty obvious that they have a 10 in common, but the largest number they have in common is going to be a 20. We'd place that number on the outside. The second step we did is look at each letter one at a time. We only have one letter, so we look at the first term. It has 3 y's. The second term has 2 y's. The most they have in common is 2. So we put a y with an exponent of 2 on the outside. Then when we looked to see what we have to fill in our blanks or fill in our question marks, we need to have 40. So 20 times 2, and we place the 2 inside the parentheses, gives us 40. On the outside we have 2 y's, but we need 3 y's, so we're lacking 1, so we're going to put 1 more with the 2y. And on our last spot, we have 20, and that's what we need. We have y to the second, and that's what we need. So when we have everything that we need, we're going to put a 1 there, because remember, 1 times anything gives back itself. So 1 is going to be our placeholder. Again, we can take our expression that we have and take 20y to the second, multiply it by the quantity of 2y minus 1 using the distributive property, and we get what's on example or what's on line 1. On problem number 2, we do exactly the same thing that we did in step 1. We look at the 4 and the 8 and what they have in common. The largest number that they have in common is 4. We place that on the outside. We look at the x's. They each have 1. So 1 is what they have in common. We place that on the outside. We look at the y's. The first one has 1. The second one has none. So they have no y's in common. We have 2 holes to fill in. And with that, we have a 4 already. We have an x already. All we're lacking for the first one is a single y. So we place y in the first spot. In the second spot, we need to have an 8, so 4 times 2 gives us 8. We have 1x already, and we don't need any more. Again, on problem number 2, we can take our result, multiply it back using the distributive property, and we have what's on the first line of problem 2. We'll take a look at problem 3. On problem 3, when we're looking for a number, we have the coefficients of 3, 2, and 1. They have no numbers in common but 1, so we're not going to put any number on the outside. We look at the x's. The first one has 2 x's, the middle term has 1, and the last term has 1. The most they have in common is 1x. We place that on the outside. We do exactly the same thing for the y's. We find out that the most they have in common is 1, so we put 1y on the outside. Now we have 3 holes to fill in for each one of the 3 terms. We go back and we take a look at that. We need a 3, we need 1 more x, we need 1 more y. We need 2 for the middle term, and we need an additional y for the last one. On problem number 4, we can take a look at again at it. It has no numbers in common, but what they have in common is an x and a y. For the first one, we need an 8xy, and for the last one, we need that placeholder of a 1, so that when we multiply it back, we get exactly what we had. On page 3, there are 10 problems I'd like you to try. The answers are on the page following this.